All right, one last thing I want to talk about for this set of videos is the concept of even and odd functions, right? So remember, an even function is something that's kind of symmetric about the y-axis, right? An even function is characterized by the equation f of x equals f of minus x. Or usually we write this in the other way. But what this says is if we plug in a positive number and then plug in the negative version of that, we get the same output in either case. So, examples of these would be cosine of x, x squared, x to the fourth, things like that. Right? Secant of x is another even function. Right? Again, these are functions who, when we plug in, say, 5 and minus 5, we get the same output. We plug in 3 pi and minus 3 pi, we get the same answer. Okay. We also have odd functions. Right? Odd functions just sort of do the opposite thing. So here I should say f of negative x equals minus f of x. Right? This is something where, say, if we plug in 5 and we plug in negative 5, then the outputs of the function are opposites of each other. So like if f of 5 is 2, f of negative 5 would be negative 2. So some examples of this would be like sine of x, x cubed, things like that, tangent. Right? These are all odd functions here. Right? What does an odd function look like graphically? Remember we said an even function is something that's sort of symmetric about the y-axis. That doesn't look too symmetric, but let's pretend it is. All right, that's actually bugging me. I gotta try this again. So that would be an even function. An odd function is something that we sort of have to reflect it across the x-axis and then the y-axis. So that would be something like, that would be something like, say, this, right? So what's the point of talking about even and odd functions here? Well, they satisfy some nice things. So there's some symmetry properties to even and odd functions. So notice here, like any negative area we have here, we have an equal copy over here. Any positive area we have here, there's an equal copy of it here for even functions. So if f is even, if we integrate it on a symmetric interval from a to a, minus a to a, we can actually just cut that interval in half because we know we're going to have equal areas in the negative numbers and in the positive numbers. So cut it in half and just compute half of the integral from 0 to a instead. Right? Now, if we look at an odd function, any negative area we have over here on the left turns into positive area over here. And we would have, likewise, if there were any negative area on the right, it would turn into positive area on the left. So if f is odd, then when we compute one of these, again, because we have an equal part negative area to the right, let's say, and positive area on the left, and vice versa, no matter what, this is always 0. So we can sort of get around doing a whole bunch of work by using this even-odd trick. So just a couple quick examples of what that would look like. So let's say we did something like the integral from minus 6 to 6 of 3x squared dx. So to verify whether something's even or odd, we just swap x for minus x. So if f of x is 3x squared, f of minus x, this is 3 of negative x squared. But when I square negative x, I just get x squared back. So that's f of x. So this is even. So this integral here, we can just double it and cut the interval in half. Right? So this one doesn't really spare you a whole bunch of work necessarily. What it does allow you to do is plug in 0, which is usually a nice thing to do. So now when we integrate this, we have 2 times antiderivative of 3x squared is x cubed from 0 to 6. So this is 2 times 6 cubed minus 0. So the nice thing here is that we don't have to compute negative 6 cubed. We just have to do 6 cubed, which is 216. So this happens to be 432. All right. Now, on the other hand, if we look for an odd function here, let's see, what's a good odd function? Let's look at something like integral from minus pi over 2 to pi over 2 of sine of x cosine of x dx. Okay, so if I had a function like this, so f of x here would be sine of x cosine of x. F of minus x would be sine of negative x cosine of negative x. All right, well, we know sine is odd, so we can pull out this negative. But cosine is an even function, so the minus just goes away. And if we look at this, this is negative f of x. So this is odd. I almost wrote do. Odd. So we immediately know that this integral is 0 because it's an odd function. And that's it. So these are some nice facts you can use if you're able to tell that a function is even or odd. You're able to use these as kind of like a shortcut to computing their integral.